Next thing we're going to talk about is the shading when it comes to graphing, what colors we're going to shade and what the lines are going to look like, etc. for the linear inequalities. So in the need to know section of the very end of the chapter, it says to graph linear inequality in two variables, follow these steps. So we're going to graph the boundary. If linear inequality includes the possibility of equality and the solution set is continuous, draw a solid green line to show that all points in the boundary are included. If the linear inequality includes the possibility of equality and the solution set is discrete, stipple the boundary with green points. If the linear inequality excludes the possibility of equality, draw a dashed line to show that the points on the boundary are not included. We use the dashed green line for continuous solution sets. We use a dashed orange line for discrete solution sets. We already talked about step 2, which was the test point. We talked about that with example 1, how generally speaking we like to choose the origin, 0, 0. If the line goes through the origin, 0, 0, we'll have to choose a different point. We'll explore that further as we get later on. So let's go back and look at this a little further here. For example, right here, we can see one when it talks right here about x is an element of R and y is an element of R. That means those ones are an element of the real number system. There are no limitations. It's continuous variation. We can also look right here that this equation has the possibility of equality. So when there's no limitations and there's the possibility of equality, everything is going to be green. We're going with a solid green line, and the shading is going to be green as well. For the second one here, we have as well, there's no limitations. We have x is an element of the real number system, y is an element of the real number system. But in this case, equality is not possible. We just have a greater than. It'd be the same if it was less than. So in this case, everything is still going to be green, but instead of a solid green line, we're going to go with a dashed green line. And the reason for that is because the solution will not be found on this line. It's going to be, in this case, greater than everything found along that line. If it was less than, what we would find is that the green shading would be down here below the line, everything that would be less than where this boundary point is. In this third one here, we have equality is possible, but now we have x as an element of the integer system and y is an element of the integer system. So there's limitations. So as we read earlier, when there's an integer, we used a stippled, as they call it, stippled green line for the equality possibility. And then we use orange shading, but stippled green in amongst the points. The points that we stipple green are going to be right on the integers. As you can see, this point right here is at the point 2 and 1. This one right here is 2 and 2. All these are integers as well. We can see right here the point 3 and negative 1. The stippling green is going to be found right on your integers. The last example of that is going to be the same idea. We have limitations, have to be integers. At this time, there's going to be no equality possible. So we have no equality possible and limitations. What we're going with is a dashed orange line with stippled green and orange shading in the appropriate spots. Now all this may seem confusing to you a little bit at first, but this is really important. You guys are going to need to commit this stuff to memory. Every time you go to graph these linear inequalities, these colors are going to be really important to you. So when you come to school tomorrow, please make sure you bring your orange and green pencil crayons so that all your graphs can be done with the appropriate colors.